Thank you very much. I'm sure that a lot of you are probably wondering why is somebody from GitHub coming to a data science conference. So I want to thank the folks for actually giving me the opportunity to be able to talk about this, because I hear the exact same thing when I go to give similar talks, when I go to talk at the Puppet conferences and the HashiCorp conferences, and we talk about workflows there because they're like, I'm doing configuration management, I'm doing operations pipelines, what does GitHub have to do with this? And I think the last conversation that actually came up was actually a really good example of from Airbnb, which is when we go out there and we actually talk to communities and customers and partners about GitHub, is we ask them, who is GitHub for? Is GitHub just for developers? Is it just for open source? Is it for large enterprises? Is it for small companies? And we actually go ahead and like to tell people that GitHub's actually for everyone. And to actually go ahead and point this fact out is there was actually a quote that actually came out last week at our GitHub Universe conference that basically says from the an IDC research firm that they actually have determined that there are 21 million software developers around the globe. But we actually announced last year at GitHub Universe that we actually have 24 million people registered on GitHub.com. So who are the other 3 million people on GitHub if GitHub is only for developers? So what we're realizing is that GitHub is not just for developers. There are a lot of other people that are writing things in things that are not traditionally what we see as code, but it could be a Python script. The last example from the from Airbnb and talking about Airflow and how you would have a Python script, that could be something that could actually live in a repository that could exist with a developer project, so you would actually know which service is actually going with which particular data set. One of the other stories that we tell around this is we have a customer, a financial services customer, that the CTO actually came to GitHub and was like, look, we've got 2,500 developers, so we need 2,500 seats of GitHub Enterprise. And so we were like, okay, that's great. So we go ahead, we work with them, and what we did is we actually put them on this special model because we didn't think that they actually only had 2,500 developers. So we did this model called a recon. And what a recon does is basically we go back to them every quarter and just say, hey, how many users are actually on GitHub Enterprise? And the first time we went out there, we asked the CTO, could you generate the report for us? He goes, yeah, there's 800 people on the appliance. We're like, okay, great, so we're within our 2,500, great. Next time we go back to him, we go, how many people? He goes, oh, there's now 2,000 people. And we're like, oh, getting pretty close to 2,500. So then the third time we go back and ask him, we're like, hey, how many people are on there? And we didn't get a response. So we go ahead and ask him again, how many people are on the appliance? No response. So then all of a sudden it's about 9 months after the fact, and we're like, look, you're coming up on your yearly renewal. We need to know how many people are on the appliance. 12,000. So all of a sudden, they had 12,000 people that needed to be able to interact with the developers. And what we found out inside their community is they did so much analytical processing that the data scientists and the machine learning folks that all worked in using Jupyter notebooks and using Python code and doing all of their data pipelines were all using GitHub. So let's talk a little bit about what a potential data science workflow actually looks like inside of GitHub. So I'm actually going to represent this as our internal data science team is where this is actually going to come from, but we actually do the dog fooding model where when our data science team uses this model, we actually go out there and we present it to our customers and to different community members, and they actually provide feedback back to us. And they're like, hey, have you thought about possibly doing this, or have you thought about doing that? So I would like this, hopefully, to actually be a discussion with the data scientists in the room to basically be able to help us learn what are other potential workflows as we go through this. Where might there be other areas where we could actually enhance this for other data scientists? So number one, let's take a look at GitHub's data at a glance. So there's actually 3 primary areas that GitHub actually collects data. So one is around the activity data. So how many people here use GitHub today? Right? Awesome. So when you actually are in GitHub and if you open a pull request or you create an issue or you create a new repository, that is all activity data. That activity data is actually then associated with what we actually call events. And those events actually get stored, and those are actually our keys that we use all over GitHub. So if you've ever heard of a webhook event out of GitHub where we actually trigger things in third-party systems, those all come off of that hook naming convention. 50% of the code inside of our 350 terabytes of data is actually residing in private data. So these are people that are actually paying GitHub that they don't want to share their projects with the world. That data that lives inside of there, based on terms and conditions, we can actually get things like metadata out of those repos. So we can't see what's in the code, but we know how many people are actually collaborating on that project. We actually know what types of languages you're actually using. And we can actually look at pull requests opened and closed across different projects. But we have no idea who you are. We have no idea what the code is itself. And from that information, that helps us keep that information private from other people. And then we have things which are what I call the me economy. So how many people in here have a LinkedIn account? Okay, LinkedIn accounts. How many people here have a Facebook account? Okay, right? These are all me economy type things. This is about what I'm doing. I went ahead and I uploaded pictures of my travels to Budapest, and I get friends that are like, oh, that's really cool. What are you doing in Budapest? And I'm like, I'm there for work. And they're like, oh, so sorry. So one of the things that we do on GitHub around that me economy is we create a contribution graph. That contribution graph is actually basically telling us when you are actually contributing back and forth inside of GitHub. Now, that little dot is actually green, and it goes from light green to dark green, determined by how much activity you're actually doing on GitHub. There are some people in the open source communities, like the Ruby on Rails, the Python, Jython, you go out and look at those projects, and it is amazing. You have a developer, like a core contributor, and their graph is completely green. But there are certain things that we actually recognize that people who actually work in large enterprises, their contribution graphs show things where they're actually contributing less during weekdays, but they contribute a lot more on the weekends. Well, we can come up with some analysis around that and make some assessments. So when I first started at GitHub 3 years ago, our data science team was actually called user experience. And that user experience team went out and queried people and tried to find out what they liked about GitHub, what they didn't like about GitHub. And it was very subjective. That color green on that button, it doesn't look right. So what we wanted to try to do is we wanted to start trying experiments. And as we started wanting to do experiments, we needed a way to be able to track, are we being successful or not successful? Lo and behold, we decided that maybe we should create a data science team. So the first step inside of GitHub that we actually use to determine if we should actually go ahead and work on something is we actually need to establish a problem definition. Now, this problem definition is actually created in a GitHub issue. How many people here have heard the term rubber ducking? Okay. So rubber ducking is this concept where if you have a problem, it's like if you're explaining it to a rubber duck. And then what happens is you get better at asking questions by thinking more deeply. So I tell everybody the way I rubber duck is I try to explain to my parents what I do every day. And then they ask me a lot of questions back, and then I have to explain more and more, and I realize they're at the end of the conversation like, you completely lost me, but it sounds really cool what you're doing. So the other thing that we'll do is alongside those GitHub issues, they will actually start @mentioning. So whenever you're inside of GitHub and you do an @mention, it actually triggers a notification. And we're actually including other people into this conversation. So if we're doing something that is going to impact a particular API, or if we're doing something that is going to impact the UI, or if we're doing something that is going to cost a significant amount of infrastructure resources, we will actually bring in those other teams into that issue to let them know that, hey, we're about to run an experiment. Do you have any concerns with this, or would you like to be part of the process? That ends up leading to a meeting. And that meeting are all of the key stakeholders, and they get together to basically understand what is the problem that we're trying to define. So this is an example of a problem. So when we go ahead and we look at source code is made up of many different pieces and parts. Now, if we can build a system that it actually can get smart about interpreting what is inside the code and create a vocabulary around that, like we were defining a sentence, so this is a noun, this is a verb, this is an adjective, we can actually start classifying those things into models. So before, when you would see other people like older IDEs and different text editors, the way they would do a lot of this is they would actually do it through regular expression parsing. And they would go ahead and just take a really large string buffer. Well, we all know what happens in those IDEs when you have a file that's 2,500 lines long and you go to scroll and it takes a long time, so we needed faster computers. So now again, I'm aging myself about actually having buffers where you would actually have to scroll through large files. So if we can take that vocabulary, what we can do is there's a feature on GitHub where if you've gone in with specific languages, we can actually go through a code review process, and in the jump to drop-down dialog, we can actually interpret all of the files with all of the changes in that change set and actually interpret where on that particular line and take you to the specific code for that particular review. So now you can see inside of a particular situation where you are working with a web team and you've got code that exists around CSS, you've got code around HTML, you've got code around JavaScript. Well, the designers are only going to be concerned about the CSS, the JavaScript developers are going to be concerned about the interactivity, and the HTML people are probably looking at HTML from marketing perspective and search engine optimization. All of those people are going to be interested in different sections of the code to be able to review. So they can actually go to that jump to dialog and they can actually start typing in and actually filter out that list, and it takes them directly to that page. That model is actually very complex inside of GitHub for us to be able to take the data and the way that we learn to be able to teach GitHub about this process. So what we did is we ended up taking those nouns and verbs and adjectives and we started creating these data models around them, and we were able to actually create full code structures out of it. So what we were starting to do is, instead of looking at code as source code, we were actually able to rebuild that entire change set from the ground up. So from that problem definition, the next thing we want to do is we want to define success metrics. Now, these will be comments that will then go in after that initial meeting of defining the problem, and we will actually put them into a GitHub issue. And again, we will come back and have another meeting to make sure that everybody agrees with these success metrics. These actually come out of some things from Google around OKRs. So if you've ever heard of an OKR, that's actually how we define a lot of these things internally. We want to start figuring out at the very end of this process, just as a regular scientist would do, if we're making a hypothesis and we want to come to a conclusion, then we better at least know what we're measuring. So then we go ahead, and this is part of the fun part, because this has nothing to do with GitHub, but this is an open source project that GitHub actually built about 7 years ago. So we have this thing called HughBot. So how many people have heard of ChatOps? ChatOps? Okay. So ChatOps, so if we take how many people were here in the room with the Airbnb talk? Anybody here with the Airbnb talk? So imagine taking Airflow, being able to go into Slack, and being able to type in a command and automatically going ahead and building out your Airflow and automatically starting to create everything. And then what happens is when the entire infrastructure is completely built, HughBot, as that bot, would go back into the issue that's describing what you want to do and makes a comment in there on your behalf that says, the data is now ready for use. How valuable would that be in your organization? How many times are you sitting there? I know when I would build code, I would sit there and, if you're building something really long, it might take 30 to 45 minutes. So you go and have a coffee, maybe you go grab lunch. Probably the same types of things happen in your organizations around building your data pipelines. This is now something you can actually then get a notification telling you that that code, the data pipeline for that particular problem segment is now ready for use. So now that we take that incoming data, that data actually comes out of GitHub from 3 primary data sources. One is a MySQL cluster. The second is a series of zipped events, which are snippets of those webhook events that we talked about before, and then using HDFS. So when we're actually taking those three actually end up making up our data warehouse. Now, the combination of those 3, we then use a combination of Hive and Presto to actually start doing some analysis on that data. Now, one of the things a lot of people think about GitHub issues is they think about that they're just for text. So it's text and emojis and at mentions, and for the really cool kids, they go ahead and attach Giphies and other things in there. One of the things that a lot of people don't realize is they can actually be very functional as well. So just like you can have a Giphy with an image, what you could do is if you've got a screenshot of a particular select statement and you're returning some interesting data, you could actually just use Sketch or something else, take a screenshot, and then just drag and drop that image into the issue and say, hey, here are the results of what we're seeing so far. Or if you've got something that's actually text enabled, you can copy and paste that text and then go ahead and format it, and we actually support SQL formatting. So if you've got SQL formatting, Python formatting, a lot of those can actually be rendered inside of GitHub issues. So then what we do is we pre-process all of that data, get it ready for usage. Now, once we go ahead and have that, what we'll do is we'll do some initial experimentation on the data by hand, just to make sure that we've actually collected the right amount of data. If we don't have the right amount of data, then we sort of go back to the beginning and start to think about, hey, did we actually establish our problem statement correctly to make sure we're going to get the data, and sort of follow that process back through again. So then we actually start what we call data exploration. How many people here know what a pull request is? Okay. Great, so a pull request for us at GitHub, a lot of people, when I go out and give these talks, a pull request is normally seen as I do a week's worth of work with about 150 commits. I go ahead and I bundle all those up and I push them up to GitHub and I issue a pull request, and I'm just looking for somebody to hit the big green button down at the bottom right hand corner that says merge. That's the actual inverse way that you should actually be thinking about pull requests. The way that we think about using pull requests is you're going to start with the smallest commit possible. So it could be something that could just be a select statement inside of a Python file. It could be a unit test that you actually are planning on writing. You do that one file or unit test, maybe there's a series of files, you do that commit and then you open up the pull request because you are requesting for other people to contribute. Now, when we go ahead and do this, there are sort of 3 models that we actually follow around how you can actually contribute. And I'm sure most of you have seen this in different scenarios. So there is one where you become the primary owner of the pull request from beginning to merge. How many people in here that do pull requests, is that the model you follow? How many people follow that model? Okay. There's a second model that you can use, that you open up a pull request with a series of commits. Somebody wants to contribute, they will actually clone the repository, change to the branch, they will actually make changes directly in the code, and then commit back the changes that they would actually like to see. How many people follow that mode? That's what I thought. I get that a lot of times, and what happens is it really frustrates me because somebody's like, they'll go into my pull request and they'll make a line item comment and they'll be like, hey, instead of using I, can we use the variable of X? Like, if you really want to use variable of X, how about you go ahead and submit a change? So there's 2 different ways. There's a third way of working with a pull request. This is you're working on a branch. Instead of me actually committing directly over your branch, if I've got a change for it, I can actually create another branch off of your branch, go ahead and submit my changes and create another pull request asking you to be able to accept my changes into your branch. Not all pull requests have to go back into master. You can actually do branches of branches. So in our data exploration phase, we follow, depending on the type of data we're manipulating, we actually use all three of those. And it really depends on in which context you're using them. The best thing to do is to experiment with all three, and it also depends on the cultural biases that you may actually have in different organizations. Am I working with an external contractor? That may require you to actually go through that fork and submit back in. You may actually have different regions, and what happens is you've got to push something forward and you're doing a follow the sun type development. That may require you just to go ahead and make the change on somebody else's behalf. The other one is a very collaborative open source project where you may go ahead and just ask somebody to be able to make a change and then go ahead and have them change it for you. Now, the data exploration, we will actually have pull requests and they will actually live for a relatively long time, because we're trying to collect as much information as possible from other people to be able to contribute back for us. So this ends up leading into model prototyping. So once we have all of that data ingested, we've opened up a pull request with a number of things that we're going to go ahead and monitor. We then go ahead and create that model. That model will end up being the place where we do our commit over commit after commit, and we keep getting comments, and we'll keep doing a regular code review cycle as those models are actually being updated. Those review comments actually lead to us actually making better code over time. Once we are done with that, there's actually two operations. One, I can close the pull request. The second is I can merge the pull request. There is a significant number of our pull requests that actually never even get merged. This is sort of like running through a science experiment and you're halfway through it and you realize that your problem statement or your hypothesis was just completely off board, and there's no way you're ever going to come to a conclusion other than I should just stop this experiment. We will close that pull request, because what we want is that zip file and everything else, we will actually use Git LFS to actually attach that data set to that branch. So what we can actually do is over time, if somebody ever thinks that maybe we should run that experiment again, they can actually see historically through search or by going back and looking at that pull request specifically, the changes that actually existed. So that way they can either say, okay, let's try this experiment a little bit differently, or maybe they pick it up because there's something new, a new data set that's actually become available, and they feel like now they can actually take it to completion. The second model is the model where, hey, experiment's actually going as planned, let's go ahead and let's merge those changes back into the master branch. Again, we use that webhook methodology to go ahead and have HughBot, who's actually monitoring what's actually going on, sees that an event has actually happened, and then what we do is we build out the infrastructure that's necessary to roll that model out into production. Now, in production inside of GitHub is basically making that data available now to the engineering teams. So what we will do is we do a lot of data as a service. So we do a lot of things in very small increments, so that data as a service can now be consumed by going ahead and productizing the model. So what we do is now there's another repo inside of the GitHub repo. So the other one's in an analytics repo. Now we're in the GitHub repo. An engineer goes ahead and the data scientist actually opens up a new issue. And that issue is basically like, hey, I'm letting you know that the data model is now ready for you to go ahead and build. That's now cross-linked between the two repos. So now we have those two things directly in correlation with one another. That will actually show up in the timeline view inside of GitHub. Now that person goes ahead, opens and creates a branch, creates their own pull request, goes through that process, goes ahead and builds out an external facing API, whether that's through a model object and a controller, or whether that's exposing that data through a third party through the GitHub API, and then we go ahead and launch it to an internal team. So we do feature flagging. So when we go ahead and do feature flagging, we will turn it on for that specific team to go ahead and play with it. Now, as they're playing with it, we're going to start measuring it. So now we have these two pull requests, one that's been merged, one that's open. The data scientists are now coming back and actually seeing what's going on and actually measuring that what they were actually expecting to see happen is actually happening. What they will continue to do is continue iterating inside of the code, and as they're using it on a day in and day out basis, they go back and they report back to the data science team. Just because a pull request is closed does not mean you can't comment on it. It just means that the commits are done. We will continue to comment even after a pull request is closed. Then what will end up happening is we will take that feature flag and we will enable it for all of GitHub internally. So we then get added as GitHub, we can go ahead and start using those features early to go ahead and start collecting more data. If you knew how many things GitHub could have released in the last year and we didn't, which hopefully the data is realizing why we shouldn't have, there's so many things that our engineers are building on a day in and day out basis. Once we get past that marker, we get the thumbs up from the infrastructure teams to go ahead and roll that out all across the enterprise. This includes performance metrics, it includes usability metrics, it includes all of these different things that we can actually feed back to the original piece. So that is sort of a very general workflow, but there are other things that we can actually do with GitHub inside of that different workflow. So the first thing is in the middle of that workflow, one of the things when we're actually trying to analyze the data is we use Jupyter notebooks a lot. Now, for those of you that don't know, is inside of GitHub, this is an actual screenshot. This is not me meddling with a whole bunch of HTML. This is an actual screenshot of a Python notebook inside of GitHub. So when you actually upload an IPYNB file, we actually detect that and we will actually render it. So the bottom, you have the in and the out. Now, the other thing that you can do with this as well is, depending on how long your Jupyter notebooks are, we actually have a lot of financial services customers that use this for their quantitative analytics systems. So they actually use this extensively throughout how they actually go ahead and collaborate with a financial analyst and how they actually share that information out with them before something may go to Wall Street or before something goes to a different news agency about what's going on in the industry. Another way that we can actually use GitHub is the Explore tab. Now this is something that we revamped last week. We actually did this over the series of about a year and a half. And what we've done is this is actually another example of one of those experiments. One of the things that we found is this is one of the, what we find out from our users, the NPS scores, the usability of this particular feature was very high, but it got accessed very little. And primarily the reason why is because the curated content that was actually inside of the Explore pane never really changed. So what ended up happening is now we have two different models. So inside of GitHub, underneath your repo, you now have the ability to be able to put tags underneath them. So when we have those tags will actually allow you to curate your repositories with this data. So what we do is we then use a series of different metrics on the back end of GitHub. So if you've got a particular repository that actually is marked with data science as the hashtag, we'll then look at how many people are following it, how many people have started, and how many forks that you have against it, and that will actually help us promote content into this particular feature. Then what we do is we will go out to industry experts. So you'll see that there's actually something on there right now that actually talks about getting started with machine learning, which basically is an expert in the field that's actually describing how they got started with machine learning, and then links throughout that particular post that actually talks about repositories around machine learning. So it's a place where you can actually go and start to learn how to use existing code. So one of the things I tell a lot of people that are getting started in a particular industry, if we have any college students who are in the room, one of the best places that I can see is going to the Explore tab, go find a repository and fork it, and then start modifying it. See what happens with somebody else's code. It's a really quick way. When I first got started with development, everything that we did was hello world. So you have a Ruby hello world example, a Java hello world example, a Python hello world example. But now we have this wealth of data that if you're just wanting to learn how to use Python for data pipelines, go find a data pipeline example in GitHub, fork it, and then see how it can apply to your own data sets. The other model that we have, the other thing that you can do from the Explorer is also being able to do search. So maybe that's the next one after this. So we talk about being able to go ahead and use data and the workflows inside of GitHub. one of the things that we've actually started experimenting a lot with is how can we actually use data from other data as a service providers to actually make it safer to be able to work inside of GitHub. So there's an application that you can actually install into your GitHub repositories. It's actually called Probot. And Probot has a number of different features inside of it. You can actually build your own. They're really easy. You can do it with about 10 lines of JavaScript code. And what it does is this particular example from the screenshot is actually being able to do sentiment analysis. So you can imagine on GitHub.com where we have all of these people, we've got almost 3 million daily active users that are coming in and collaborating on these open source projects, that there's some people who come in and troll inside of specific projects, and they'll make comments that we don't appreciate. So what the sentiment bot could actually do automatically is using data and actually looking at the comment that just took place, can actually go out and actually respond back, notify the admins of that repository that somebody's making this kind of remark, can automatically flag that particular user as spammy, can automatically go back in and give a comment back to your contribution guidelines to be able to say, this is not the way that we work inside this community. Then there's all other types of applications that you could actually be having that for internal, inside your company. If you've got somebody who's a repeat offender and doing this constantly, looking at commit histories, looking at different types of word combinations, you could actually flag that, unfortunately, inside of like HR or something else, creating your own safety inside of your company. So this is where the search comes in. So based on those particular tags, up at the top, you'll see that you've got repositories, code, commits, issues, wikis, and users. So when you actually use a search and you go ahead and type, you can actually go ahead and actually ask for particular file types. You can ask for specific regions. You can ask for repositories that have been modified in the last 6 months, ones that have a high number of stars. All of those different combinations and permutations actually come back out for you to be able to find something that you may be specifically looking for. This is probably something that when I go out and I give talks is probably the least used feature that probably has the highest value inside of GitHub. I can't tell you over my lifetime in software development how many places I've gone in and somebody's like, you're not going to believe this really cool thing that I've built. And I go into GitHub and I mean, oh, you mean like these other 3 things that look just like it? Yeah, you're not the first one to have thought about this concept. So this is a place for you to be able to go out and find other projects that might meet needs for you. Now, outside of GitHub.com, GitHub actually participates in a lot of other open source projects. So one of those projects that our founder actually started about 4 years ago that got released 3 years ago was something called Atom. Atom's built on top of it's built on top of Google UI's framework that's used in Chrome, which we actually have another product for called Electron, which allows you to be able to build cross-platform applications that tie natively into the operating system. So there's actually a plugin into Atom that actually allows you to be able to run Jupyter notebooks. So if you go in and look at packages underneath Atom, what will happen is you put in your Jupyter notebook, and what you can do is you can control toggle off of that. And what will happen is that will automatically run the execution of that Jupyter notebook directly in that particular window. So the great thing about this is not platform dependent. So if you're on a Linux box, if you're on a Mac, if you're on a Windows box, you can even take some of these apps and actually run them. There's actually another one which is you can just take that Jupyter viewer and you can actually run it on an iPad. So you can actually type it in or actually run everything on an iPad if you're on an airplane or something and you just need quick execution of data from there. The other thing is this is probably one of the most unique uses. This has popped up probably over the last year as a very interesting use case. So how many people here know what GitHub Pages is? Okay. So GitHub Pages, a lot of people don't realize that GitHub is actually the world's largest web page rendering farm in the world. We also accept the most traffic for custom websites. So you can actually go into a repository inside of GitHub And actually, you can just use a template, which will basically take your repository and you basically use markdown files, and the markdown files end up using a framework called Jekyll, which will allow you to be able to create an HTML static website. You can actually run that on github.com. No need to deploy to a third-party site, no need to send that to S3 on Amazon. We'll actually host it for you. You can even use your own CNAME DNS mapping back to it. Well, one of the things that we found is that there's actually a very large constituent of people that are actually storing open data. They're actually taking data, whether it's from government or whether it's from a project that they did, it was from an internship, and they're actually uploading that data into public data sets. So they're actually running that on Amazon or Google or some other third-party service, and they're exposing that data so you can actually consume it as JSON. And what they'll do is they'll actually use a JavaScript data visualization framework, something like D3. They'll embed that into their web page that's actually running on GitHub. And what they'll do is they will actually go ahead and pull the data out of those public data sources. When they actually go ahead and do that, there's actually examples that now you can actually make them interactive. So what happens is you actually go ahead and you're using JavaScript, you type in a word, and you can actually search for things using that web page without any need for you to actually having to set up the model view controller layer and having to put in a whole bunch of logic and having to learn Ruby on Rails or Django or some other framework. You can just do it all directly from Markdown and JavaScript. As we're starting to see this emerge, one of the first thing that happened was our infrastructure team got really nervous because all of a sudden we were basically opening up these firewall ports that basically it's just an HTTP connection to go get that JSON data, which from a GitHub perspective, we have to let HTTP out. So what ended up happening is they immediately were like, hey, we should turn this off. The first thing that our data science team said, this could be an opportunity. So now what we're doing is we're actually monitoring these particular repos that actually are building these types of applications, and we're looking at the endpoints where they're actually collecting this data, and again going ahead and learning from that to be able to say, is this a model that we see people are going to want to do in the future? So if we start to see this as an uptick in people wanting to be able to use it, we'll start building out documentation and best practices and other ways for people to actually use GitHub Pages in this way. So from there, there's a lot of different ways inside of GitHub. I tell people that whenever you think about a tool, I'm sure that there's other products and stuff that you use inside of your companies. One of the things that happens is we only ever use what's directly face forward in front of us. So we use a lot of times only about 20% of that actual application's capabilities. So one of the things that I actually encourage a lot of you to do from here is if there is something that maybe you're currently working on and maybe you've got a problem that you're trying to rubber duck, maybe you've already gone to Stack Overflow and nobody has given you a solution to that problem, come to GitHub and use our search and go out there and try to use some of the different parameters to be able to see if maybe there's a project that already exists on GitHub that might be able to solve your problem. So with that, I thank you and I'll open it up to questions.
All right, thank you so much. Before we go into the questions, I would like to give you this little token of appreciation here.
Wow, thank you very much. That is awesome.
From us at Crunch. So we got a couple of questions here. The first one being, when will GitHub support version control for data?
So that's a great question. So it really depends on the way that data is actually structured. Obviously, anything that's text, we can version today. There are some very interesting open source projects that we're actually looking at today that will actually allow you to be able to look at states of different data repositories and actually being able to use Git SHA mechanisms to be able to restore them back to a particular point in time. As those start to emerge as things that we can actually start to store inside of GitHub, that's when we'll be able to go ahead and actually start leveraging those to be able to share those out to you. I really wish I could give you a date, but at least the good news is right now, at least we are aware that this is something that our customers want. So it's something that we are looking to be able to support in the future.
I'm actually looking forward to that. So, next question. Have you tried to run machine learning algorithm on GitHub public codes to teach a machine to code?
So, if any of you can go back, this is a sort of a two-part answer. So, the first one is our CEO, Chris Wanstrath, last week. We were actually talking about this. Miju Wan, who is actually head of our data science team, he actually came up after her keynote last week at GitHub Universe, and he even mentioned, he was like, just imagine somewhere down the road where we can actually use machine learning, that as you're starting to type, that we can actually start to say, hey, we've already found people that have written code that looks like this. This is what the rest of the snippet would look like. Would you just like to go ahead and pull that in so you don't have to continue typing? The second part answer to that is people, just like self-driving cars, it's kind of like, what sort of guide rails do we put around that to make sure that the code that we're actually learning from is actually of the quality that I would actually want to be able to do. One of the things that I tell a lot of people is on github.com, and this is nothing, I don't mean this derogatory in any way towards college students, but there's a lot of people who are learning to code and using GitHub repositories, and it's their first time ever writing any code. So yeah, that's not necessarily the code that I would want to be copying into my production code that I'm going live with.
Yeah, you don't want that. I was just thinking myself an example. Not good. All right, next question. Can you do machine learning model versioning through GitHub? If yes, could you tell how would you work it? How would it work?
So yes and no. Again, it's one of the things that we have is depending on what you're actually trying to do. So we even have some people, the machine learning models, we've learned a lot from being able to do the Jupyter Notebook rendering. So one of the things that we have is we actually have a pretty large rendering team. And so one of the things that we're trying to figure out how to do is being able to take those lessons learned to be able to do MI models and being able to version those in the future. The good news is that team on the rendering side sort of got reallocated to other projects. And now with the introduction of our larger data science team, they're basically coming back and saying, look, if GitHub can't support this for us, then we're going to have to go find other tools. And no engineering team ever wants to hear that their internal team's going to go look for an external thing, knowing that they could build it themselves. So that's something that definitely I could expect to see probably in the next year or two.
Nice. Next question from Anonymous. Are there plans to build a code search similar to Google one among many repositories?
So that actually does exist today. So whoever asked that question, if you can come up and find me afterwards, it's not necessarily, if you're talking about Google where you start typing words and then you get like suggestions afterwards, there are no real plans for that right now. If it's just being able to search and being able to get contextual representations back to be able to see where things live, that exists today. So, but yeah, if you're trying to do the autocomplete type model, that's not something we're currently working on.
Next one. Any plans to provide hosted Jupyter notebooks?
So as I showed, you can actually go out and do a search for IPYNB file types, and you'll actually see that you can actually put in Jupyter notebooks today into GitHub. They'll actually render. The biggest question there is one of the things that we hear from people is they actually want to connect to external data sources and then actually pull that data across. Right now, a lot of the work that's done with Jupyter Notebooks is they'll export sample data sets or even complete data sets, and they'll actually put them in as JSON, and they'll put them into their repos, and then they will load them based on the file structure. So if you're looking to be able to connect GitHub to external data sources, that's not something that's currently on our roadmap.
Next one, when will GitHub build an IDE? I guess.
So Atom is our text editor. We announced, I guess, about 3 weeks back that we are now working with Facebook. And Facebook built a module for Atom for their teams internally. So now we are officially having what we call the Atom IDE. And basically, it's not an IDE like you would go and grab something like IntelliJ. What it is it's basically still a text editor because we want to keep it really lightweight. And then what will happen is if you want to make it an IDE, then it's something that you have to opt into instead of giving you a whole bunch of modules that you probably would never use for something really small, like just a really light text editor, and then trying to figure out how to uninstall all of those modules.
All right, I think we got time for one more question. Do you do analytics for the project dependencies? Would be great to have something similar to the page rank on the GitHub.
That is a great question. That actually goes to a team inside of GitHub, actually called Social Impact. And one of the things, we actually have an internal ranking. If somebody's actually interested, you can actually do a request and you can sort of figure out where you are in the grand scheme of all projects inside of GitHub. The biggest issue that we run into is making sure that developers don't gamify that particular page ranking. So if all of a sudden we start using a particular data science model to figure out which repositories are quote unquote better than other ones, then what ends up happening is they'll end up possibly paying people to come contribute. And they might just contribute a line of documentation just so they can have an additional contributor. So, and then once they figure out what we're actually using to use for that analytics, they'll start gamifying that on the back end just to be able to increase their page rank. So we've done a lot of analysis on that. We've also talked about doing the same thing for developers, but then it was the same type of conversation. How do we make sure that developers don't gamify that particular model? So if anybody has some really great suggestions on how we might be able to do that, we're more than willing to be able to take suggestions.
Cool, there you go. That's a good opportunity. So one last round of applause for Lee. Thank you so much.
Thank you.